Hello, this is Mr. Eric, and I'm here to talk to you about Lesson 5.1, the first lesson of Chapter 5, which is about angle and segment bisectors, specifically as they relate to triangles. So it's bisectors of triangles. The first thing you need to know is if we're talking about a segment bisector cuts that line segment in half, no matter what way it goes through. So I've kind of drawn one here that was at an angle, cuts this into two equal pieces. That's a bisector. And then if we have a perpendicular bisector, that's a specific bisector that is also at 90 degrees to that line. We have a couple of theorems that are extended from that that say, if it's a perpendicular bisector, it's at 90 degrees to the line and it cuts the line directly in half. There's another one that says any point on that bisector is equidistant from the two vertices here on the point that it's going through. So we know no matter where we are on this, we are equidistant, meaning that we're turning this into basically an isosceles triangle here. Any point up here that we go through, that we have a perpendicular bisector, if we go through that top one of the triangle, it's isosceles. Okay? The next thing they talk about in the chapter is concurrent lines. It's where three or more lines come together and cross. These are things that you'll need to have in your notes. They're the highlighted parts. Make sure you're reading through this. And then the point of concurrency is where all of those lines cross, that single point where all of them cross. So we have a point of concurrency when we're dealing with the angle bisectors, or not the angle bisectors, the segment bisectors here. If we have a perpendicular bisector for each segment of that triangle, and you can see my drawing's not entirely accurate, just know that it's not to scale, okay? Then this point is called the circumcenter. And the circumcenter may not be equidistant from those sides, but it is equidistant from the vertices of the triangle. So again, my drawing doesn't look great, but these dotted lines here would represent the exact same distance from each one of them. On page 326, you might take a close look at that one. It'll probably come into play later on, especially when it comes to the test, that the circumcenter can be in different locations, such as outside the triangle or perched on one side of that triangle. The next thing they talk about in this chapter is the angle bisectors. We, of course, know that if you take an angle and you do some construction work here, you can go back and look at that one. Look at that lesson from earlier. If we do that, we can cut this angle exactly in half. And on page 327, you'll need to take a look. There are some theorems there as well. One of those being mainly that any point on this angle bisector is equidistant from the sides. So the second one, I believe, is that if there is a point that is equidistant from the sides, it has to be on that angle bisector. Now, if we bisect all of the angles of a triangle, we have the flip side of our circumcenter. It's called an incenter. And that's where all of those angle bisectors would meet, somewhere probably in the middle of the triangle. And it would make a point that is equidistant from all the different sides. So it'd be the same distance to each side. Now, the only way I think you can have an incenter and a circumcenter that are in the same place is if you have an equilateral, equiangular triangle. So you'll need to be aware of things like that. Make sure you take a look at the further guidance. There's a lot of information. Make sure you're getting the vocabulary information down into your notes, and you're putting those theorems down as well. There's a lot of information in this lesson. If there was something that you didn't understand from it or that you need clarified further, be sure to ask me those questions when we see you in class.